Hello again. In this video we will compare both braced frame and unbraced frame, and we will see the effect of bracing. We will discuss three aspects: the stress, deflection, and the reaction forces. As you can see from this picture, when having a braced system under a lateral load, the deflection is small, but when having unbraced system, deflection is higher. So we have this experiment. So here we have this simple prototype as a structure, and this book was added to simulate the fixation of this structure to the ground, and a lateral load will be added now. And here, as you can see, the deflection is high. The other case is having a braced system. The conditions are all the same. The only difference we have here is that the system is braced. So let's see what happens when applying the load. As you can see, in the first iteration, we don't have the same displacement. And once again, here we don't have the displacement we had before. And now let's go to SolidWorks and compare these two cases in terms of deflection, stress, and reaction forces. So the simplest way to do this is to start a 3D sketch. And here, I'll start with a center rectangle. I want this to be on the XZ plane, so I will hit the tab button until I get to this plane. And after that, I'll set these two lines to be equal. And I want this to be 100 millimeters. And I want this line to go along with the Z-axis. And I want this to go along the x-axis, and here I have a fully defined square. After that, sketch a line here, and then hit the tab button until it's parallel to the y-axis, and then you need to do the same with the rest of the corners. Now, I want these to be equal, and this length should be 200. Then, draw a corner rectangle, start here, then hit the tab button until we are parallel to the XZ plane, and then snap to this point. The final thing is the bracing. So simply connect these points. Finish the sketch, and then go to weldments, and from structural member, go to the GB, and here you will find round bar, and then select the smallest one, 5.5, and you need to select these lines, then start a new group, and select the base, and then a new group, and select these four, and finally select a new group and select the bracing. Then we need to assign a material, and here under steel I will select ASTM A36 steel. And now go to simulation, in your study, and I need to start a static study. Starting with the fixtures, I need to fix the base, so I will select these to be fixed. So they won't move, they have 0 degrees of freedom. And for the loading, I need the gravity load, and the direction is correct. And I need a force, and I will apply it to a joint, and I need to apply it here and here to these joints. I need to select a reference plane, and I want this one, and I want the load to be normal to the plane, and the value should be, let's say, 200 newtons, and this is the direction. If you cannot see the direction clearly, you can go to the symbol settings and you can increase this. So the direction is correct. Then you need to mesh and to run the analysis. So select mesh and run. So this is the result when having these members we will talk about it after we run the analysis without these elements. So let's start a new study. Let it be static once again. And here we need to go to the last two items and then select exclude from analysis. They have no effect now, so we go to fixtures again, and we need to select these nodes. And for the loading, we need the gravity load, and we need to apply the same load we applied there so we can compare. I'll select this one, and I want the load to be normal, and the value is 200 newtons, and the direction is correct. Then hit OK. And here, mesh and run. So it's obvious that here, the maximum stress we have is higher than the yield strength, which means this system fails. And you can see the maximum value here is 6.6 multiplied by 10 to the power of 8, while the yield strength is 2.5 multiplied by 10 to the power 8, which means the system fails. And in terms of displacement, here we have the maximum displacement, and we are talking about 9 millimeters. If we go back to this study, in terms of a stress, as you can see, the maximum stress we have is 2.2, but this time it's multiplied by 10 to the power of 7, which means it's way below the yield strength. And in terms of displacement, the maximum displacement we have here is 0.008 millimeter. And that shows how bracing the system helps in terms of displacement and in terms of stress. If you go back here, you can see the stress distribution. And these elements are loaded, and for the rest of the structure, the load is not that high. But if you come here, all the columns are loaded, and they have the maximum values here. And for the displacement, you can see that we have 9 millimeters. So it's obvious that when having a lateral load, the best option we have is placing some bracing, and that's why they are used. And this is the difference when having them and when we don't have them. Another important aspect that must be taken into account when comparing both systems is the reaction forces. Here, if we right-click results, we can find list result force, and we can select these joints, so we can calculate the reaction forces. This is the X direction, and here you can tell that these joints are almost the same when it comes to reaction forces, and these two joints are almost the same when it comes to reaction forces. Now we need to keep these values so we can compare both of them. So I will keep this here. And now let's see the other case when having the system braced. And here we can do the same. So here it's obvious that these two joints are almost the same, and these two joints are almost the same. But if you compare them, it's obvious that these elements transmitted some load to these joints, because here you can tell that we have a huge difference in the values, like the reaction on the X is 0.6, and here it's minus 67. And the most important one here is the X on this side. It's obvious that the load here is greater than it's in this case, because here the maximum is around 33 newtons, and here we have around 200 newtons. And that must be taken into consideration when designing concrete bases. So here are the three differences we have. The first one is the stress, and the second one is the displacement, and the third one is the reaction force. I hope guys you find this video useful. Thanks for watching and see you in another video.